A single gecko foot generates about 10 newtons of adhesive force per square centimeter. To support a 75-kilogram human on a vertical wall, you'd need roughly 70 to 80 square centimeters of perfectly clean adhesive surface on each hand. Your palms are roughly 75 square centimeters each. The math barely works. But here's the problem. Van der Waals adhesion only works on clean, dry, smooth surfaces. Dust, moisture, oil from your skin, paint texture, any of these would destroy the adhesive force. And when you try to unstick your hand, you don't just release, you peel. The force required to break those molecular bonds concentrates at the edge of your contact area. Peel too fast, and you'd take a layer of epidermis with you. You'd climb one wall and come down bleeding from every fingertip. Then there's the webs. Every version of Spider-Man shoots webs from his wrists. Real spiders do not. Real spiders produce silk from specialized organs called spinnerets, located at the rear of their abdomen, not their arms. A spider's silk glands are essentially protein factories. The spider synthesizes liquid proteins called spidroins, stores them in a sac, and threads them through a microscopic nozzle that stretches and aligns the proteins into solid fibers. The result is a material that, by weight, is 5 times stronger than steel and more elastic than nylon. But here's what nobody mentions. Producing that silk takes an enormous amount of metabolic resources. A typical garden spider produces roughly 100 meters of silk per day. That sounds impressive until you realize the spider weighs less than a gram. A human-sized silk production system would require you to synthesize and store several liters of protein-rich fluid somewhere in your body. Your body already struggles to produce enough collagen to keep your skin intact. Now it needs to manufacture industrial-strength polymer on demand. And where would you store it? Spiders store silk liquid in specialized glands. You don't have those. If your body tried to grow them, they'd need access to raw material, your digestive system maybe, which means your webs would be, biologically speaking, a modified digestive secretion. Let that sink in. Even if you could produce the silk, shooting it would require enormous pressure. Spider silk exits the spinneret at very low speed. To shoot a web line 20 meters, as Spider-Man routinely does, you'd need to accelerate a thick protein strand to roughly 15 to 20 meters per second from a tiny orifice in your wrist. The pressure required would be roughly 200 to 300 kilopascals. For comparison, a human sneeze generates about 10 kilopascals. You'd need to expel fluid from your wrist at 20 to 30 times the pressure of a sneeze. The orifice would need to be reinforced with tissue stronger than anything in the human body. Without that reinforcement, the first shot would tear your wrist open from the inside,